So when we start talking about permutations, and before we talk about combinations, we're going to talk about the easiest way to think about ways to group people. And that's what we're talking about here is how many different ways can I organize a number of things with order mattering. So let's say we just have these three people, for example, and I want to know how many different ways can I arrange these three people. So we'll say they're going to stand in a line, and there's a first, a second, and a third position in that line. How many different ways can I put these people in line? And I just want to know the number of different possibilities that exist. So one way to do this is just to list out all the possible ways to have this done, right? We could say, well, maybe Abby's first, Ben is second, and Carl is third. And we could say, let's keep Abby in the first position and put Carl second and Ben third. So this is two possibilities. But now at this point, we've run out of ways to put Abby first. There are no other combinations of Ben and Carl that I could use on the end there. So now let's put Ben first. Ben's first, and then Abby's second, and Carl is third. Okay, and we can keep Ben in first and put Carl second, Abby third. And again, we've run out of ways to put Ben first. That would be unique, different arrangements of these people. So now let's try Carl, Abby, Ben, and then finally Carl, Ben, Abby. So it looks like here there are 6 different ways to do this. And the way that we come up with this mathematically to make this easier for ourselves is we have to try to think about this in terms of multiplication of possibilities here. So for example, think about this first position. There are 3 people you could put there. You could put Abby, Ben, or Carl there. Once you put someone there, there are only 2 people left to choose to put in that spot. And then finally, there's only 1 person left to put in that spot. So it turns out if you multiply all of these three numbers together, you get 6, which is the same number of possibilities we came up with doing this just by listing them all out. And here's the reason we don't want to be listing them all out for the rest of our lives. Because, as it turns out, these can get a lot more complicated if we add more people. So now we've got more people involved. And now the number of possibilities changes. So now we have 5 people. And let's say, for the simplicity of this problem, let's say there are 5 positions for them. Well, just like the reasoning that we just used, there are 5 people now that you could put in the first spot in this line. But once you've put one of those 5 people there, there will only be 4 more people to choose from to put in position 2. And then there will be 3 to put in position 3, 2 left to put in position 4, and finally 1 person left over in that 5th position. So the way to figure out how many permutations there are of these 5 people is just to multiply those numbers together. And you could list them all out, A, B, C, D, E, and then you'd have to do A, B, C, E, D. And then it'd be going on forever and ever and ever. It'd be a lot of possibilities because as you're going to see here, this number is very large. So 5 times 4 is 20, 20 times 3 is 60, and 60 times 2, there are 120 possibilities here. So mathematically, the way that we're going to say that we calculate the number of permutations, at least in this specific case, is to choose n, I'll say people, because n could be any number, from a group of n, just do n factorial. And that factorial just means, remember, whatever n is, multiply that number by every integer that is less than that number. So, just real quick, if we had 18 people and we had the same exercise, and we said there are 18 people here and 18 positions, we would do 18 times 17 times 16 times 15. And obviously the point of this is just to get you to see the logic behind why it is that we do that multiplication. But I am going to make this a little bit more challenging now. Let's say there are not 5 positions. There are still just the original 3. This changes the problem a little bit, because we still have 5 people who can go here. And from that, there are 4 people left who could go there, and 3 people left who could go there, but there is no more position 4 or position 5. So this still holds true. You can still use this if you're choosing less than the group that you have, if you're choosing a smaller sample of that group. So in this case, if from a group of 5 people, I didn't want to choose 5 people, but I wanted to choose 3 people, then I would just do 5 times 4 times 3. 60 different ways that this can be done. So these problems change a little bit depending on the number of people you choose. So let's try to formulate a way to do this now. So to choose, and instead of n, we'll say k people, because it's not going to be equal, from a group of n. And I'm going to say where k is less than n, because in this case we've got to make sure that that value is less than the whole group that we have. So how do we calculate this now? Well, what we've done here is sort of like what we did last time. We did say 5 factorial. But remember, we didn't really include those last 2 positions because we didn't have a 4th and a 5th position. So a way that we can view this in terms of a formula we can use in the future is, let's say that we did do 5 factorial, but we divided by 2 factorial, so that that 2 and that 1 would cancel. And the reason that we multiplied by 2 factorial is because of the 5 people we were choosing from, we only needed 3 of these positions. So the way that we can look at this, if things get more complicated and we get larger groups of people, we're going to say that we still do n factorial, but we have to divide that by n minus k factorial. So in this case, we were choosing 3 people from a group of 5 people. So we did 5 factorial and divided it by, what's 5 minus 3? 2 factorial. And so these 2 formulas are the first 2 formulas that we're going to use when we're calculating our permutations. Now really they're not 2 different formulas, because you could say that this formula really is this formula. And in fact, the first time we did this, we really did do the same thing, right? Because I could go back to that example and say, let's say we are going to put back our 5 positions. I could do 5 factorial divided by, and if I wanted to pick 5 people, 5 minus 5 is 0, 0 factorial. And I could still use this rule in this case. And if you put this into a calculator, you might be surprised to find that this does equal 120, because 0 factorial is not the value that you might think that it is. But this is not something you need to worry about right now. Just think about using these 2 formulas, and we are going to do some practice problems based on this idea of permutations.